Hey everybody, we're ready to start division of rational expressions. So let's, before we get into the examples that are on here, let's go back in time and think about what we did in elementary school when we divided fractions. So if we had a problem like 3/5 divided by, let's say 6/7, something like that, right? So if you remember what we did in elementary school, there's a little process let's see, what did we do? We kept the first fraction as it was. We changed to multiplication, and we flipped the second fraction. And so we basically changed the division problem to a multiplication problem. You might wonder why this works. Well, if you take something like, let's think about multiplying by a half. If you take 4 times a half, we know that's 2, right? Half of 4 is 2. That is a multiplication problem, but as a division problem, we would do 4 divided by the reciprocal of 1/2, which is actually 2, right? So 4 divided by 2 is the same as 4 times a half. When we multiply by a fraction, it's the same as division by the reciprocal. If we divide by a fraction, it's the same as multiplication by the reciprocal. I had a student tell me once they learned the rule, keep, change, flip, which is a good rule to remember as long as you know it only works for division of fractions. So keep the first fraction, change division to multiplication, and flip the second fraction and then do the multiplication. And then we could say, well, 3, we could do cross canceling just like we did before. 3 goes into 3 once, into 6 twice. If there is cross canceling that you see in the division problem, don't do it. You cannot do cross canceling until it's a multiplication problem. Okay? But now we can do 7/10, and there's our answer. All right, so let's do the same process here, right? So dividing two fractions. So we keep the first fraction, x over x plus 3. Change division to multiplication. And flip the second fraction, we have x minus 1 over 4. And then we could look and see, well, is there anything we could cancel, anything we could factor? No, not in this case at all. Some people might be tempted to cancel the x's, but we cannot do that because this x is held together by addition with the 3. So we have no choice but to multiply straight across. X times x minus 1. 4 times x plus 3. And I would just leave my answer like that in factored form. You could distribute these, but there's no need to. Okay? In fact, it might be useful later on in our lives to not distribute those. All right, let's look at the next one. I'm going to zoom in a little bit. Oops, that's zoom out. That's not good. Let's zoom in. And it'll focus. Zoom in again. All right, focus, and that's a little better. So this is a little blurry, but that is a division sign. And so we have 3t over 2v. Let's rewrite it as a multiplication problem. So keep the first fraction, 3t over 2v squared. Change division to multiplication. Flip the second fraction, 6t minus 9 over 3tv. All right, now we can see, can we factor, can we cross cancel? Let's see, 3's will cancel, right? T's will cancel. We can factor a 3 out of these guys, so 3 times 2t minus 3. All right, and I don't think there's anything else we can do. So we multiply straight across. Let's see, these, there's nothing here but a understood 1, right? So 3 times 2t minus 3. All right, over 2v squared times v is 2v cubed. All right. That's it. We can't cancel anything else. And that's good. V squared times v gives us our v cubed there. And that's all we can do. Let's look at the next one. All Alright, division problem. So we keep the first fraction, change division to multiplication, flip the second fraction, and now we can look to see if we can factor or cross cancel or any of that. So I notice this trinomial, I can probably factor it, right? Into two binomials. Two factors of 24 that add up to 10. Well, that one's pretty easy. X plus 6, x plus 4, right? X plus 4s will cancel. By the way, that's gone now, right? And let's see, 6 and 10 have a common factor of 2. 2 will go into 6 3 times, into 10 5 times, right? And so what do we have here? Equal sign. Big equal sign. All right. So on the top here, we just have the 5. On the bottom, we have a 3 times x plus 6. And that would be a fine answer. Again, if you want to distribute the 3, you can, but it is not necessary at all. Alrighty, so let's look at the next one. Keep the first fraction, right? b minus 7 over 16. Change division to multiplication. Flip the second fraction. 8 over 7 minus b. Okay, so you hopefully recognize right away the 8 will go to 16 twice, right? And these two guys, if you remember something we did in the last section, if you have a b minus 7 over 7 minus b, those are just opposites of each other, and they become -1 basically when you divide them. So you can cancel them and make one of them -1, one of them +1, so that you have -1 over 1. And now what do we have? Well, the only thing we have on top then is a -1, right? On the bottom, 2 times 1 is 2. And so we get -1/2. And we've reduced it and divided, which is what we were asked to do. Alright, this next one looks a little challenging, but I think we can handle it. We keep the first one, right? M squared plus 2mn plus n squared over m squared plus m. Change division to multiplication. And then we flip the second one. M squared minus 1 over m squared minus n squared. Okay, let's see if we can handle this now. There's a lot of factoring we can do, I believe. This trinomial here, I think we can factor it. It's a perfect square trinomial. The first term's a perfect square. The last term's a perfect square. I think we can factor this into m plus n times m plus n. So we have this thing times itself. We could also write m plus n quantity squared, but I think this might help us more with canceling things. So we factored that guy. This guy down here, we can factor an m out of both terms. So m times m plus 1. That'll work, right? So we factored that guy. This is a difference of squares. We can factor into m plus 1, m minus 1. We factored that guy. This is also a difference of squares. We can factor into m plus n, m minus n. Alright, so now we can cancel out an m plus n. We can cancel out an m plus 1. And I think that's it, isn't it? Yeah, I believe that's it. So let's write what we have left. On the top, we have m plus n times m minus 1. On the bottom, we have an m times m minus n. And that's our answer. We can't reduce anymore. There's nothing else we can cancel out. All is good. So this would be our answer. Oh, we have one more of these, and yeah, it's probably an ugly one. Yeah, lots of stuff going on here. I'm going to rewrite it, and maybe I'll rewrite it down below here. Keep the first one, right? 27 minus 3k squared over 3k squared plus 8k minus 3. Switch division to multiplication. Flip the second one. 6k squared minus 19k plus 3 over, let's see, k squared minus 6k plus 9. Alright, so now let's go about our factoring. Let's see, we can factor 3 out of these, or this guy, right? Yeah. So let's factor 3 out. That gives us what? 9 minus k squared. Let's factor that. Let's factor this guy. Well, maybe I'll leave that one. That one looks a little ugly to factor, doesn't it? But let's factor this one. It looks like the easiest one out of the bunch here. So we need two factors of 9 that add up to 6, negative 6. Probably 3 and negative 3 and negative 3, right? So we have k minus 3, k minus 3. I think that will work. Yeah. Okay. We can factor these guys, right? So if you remember, sometimes these are not the easiest to factor. So what we can do is use that old procedure we had. Remember, we took 6 times 3 to get 18, right? So let's do that. I'll do that at the side. 6 times 3 is 18. We need two factors of 18 that add up to negative 19, right? So I think so negative 18 and negative 1 would probably work for that one, right? Then we're going to write this with 4 terms, right? 6k squared minus 18k minus k plus 3. So we wrote the middle term, the negative 19, with the negative 18 and the negative 1. And then we factor by grouping, right? So we can factor a 6k out of the first two things here. 6k times k minus 3. And we can factor a negative 1 out of these two, I think, and get a k minus 3 again, right? And then what does this become here? Well, we have a k minus 3 in both of these groups. So this becomes k minus 3 and times what's left, which is 6k minus 1. So we factored that one. Now we have this guy right here to factor, right? So we have the 3 and the negative 3, right? So let's do the same process. I'll do that over here. Maybe I'll do it up above here where we have room. So 3 times negative 3 is negative 9. We need two factors of negative 9 that add up to positive 8. Probably a 9 and a negative 1, right? And so we could write it with 4 terms. 3k squared plus 9k minus k minus 3. Then we're factoring by grouping. We can factor a 3k out of the first two. That leaves me with a k plus 3. Factor negative 1 out of the next two. That leaves me with a k plus 3. And then we have these two groups that both have a k plus 3, right? So this whole thing becomes k plus 3 times 3k minus 1. Now, you could have used guess and check on those if you're one of those guess and check people. I like this process because it's more straightforward. I don't have to spend a lot of time guessing and checking. All right. Anything else that can be factored? Oh, there's one more thing, right? This 9 minus k squared, although we factored the 3 out, this thing in parentheses can still be factored more. We can factor it into, it's a difference of squares, so we could factor into 3 minus k and 3 plus k. So I'm actually going to rewrite this so we have everything looking good. So we have this 3. This difference of squares can be factored into 3 minus k, 3 plus k. All right, on the bottom here we have k plus 3 and 3k minus 1. We're multiplying by, let's see, k minus 3 times 6k minus 1 and k minus 3 times k minus 3. So let's cancel out all that can be canceled. K minus 3s I noticed right away. 3 plus k is the same as k plus 3. Those are exactly the same. Addition doesn't matter what order you do it in, so we can cancel those out. And there's a k minus 3 and a 3 minus k. So if we subtract in the opposite order, remember those are opposites of each other, we can cancel those, make one of them negative 1, one of them positive 1. Because if you divide 3 minus k divided by k minus 3, you will get negative 1. Alright, so let's see. I don't think we can cancel anything else out, so let's just put everything together. 3 times negative 1 is negative 3 times the 6k minus 1. On the bottom, we have 3k minus 1 times 1, which is just 3k minus 1. That's all we can do. You might be tempted to cancel these 3's, but you cannot, because the 3k is held together by subtraction with the 1. It's not a product. It's not multiplied by a bunch of things down here. It's multiplied by the k, but then it's subtracted, so then we're subtracting, so we can't cancel those 3's. If you do, it's bad news bears. So this would be our final answer. Alright, so that's division with rational expressions. We'll see you on the next video in section 6.3, I believe.